Okay, so for today's class we have moments. This topic is for Edexcel M1, and this is the last topic that is left for the syllabus from Edexcel M1. And this is the theory is not very much. This is the same old moments that we have done in IGCSEs or the GCSEs. So moment we know it is what? It is equals to F times D, right? The perpendicular F and D is the product, okay? And the force should be force and the product of the perpendicular distance. Or there's another definite formula, or sorry, definition. The better way to explain is this, that line of action of force is perpendicular. Perpendicular distance from the line of, what was the correct definition? I forgot it. Let me explain it to you. For example, we have, this is a pivot. Pivot is the point around which around which the block or the plank or anything which is it is rotating. This is the pivot, let's suppose. And if there is a force that is being applied over here, so this is the force, and this line of action of force is perpendicular, and the distance, perpendicular distance from the pivot to the line of action of force. Yes, this is the correct one. It is the perpendicular, you take the distance which is perpendicular to the line of action of force, and this product would give you the moment. Moment would be generated, and this would be F into D, and the units are Newton meter. And there is a direction as well. So this force would right now produce a moment which would turn it right like this, turn this plank or anything. What is it? Let's suppose this is a simple plank. Okay, it would turn it clockwise direction, in the clockwise direction. Clockwise direction. So you have to, first of all, this direction is also important. You have to analyze which force would turn the plank or anything, the system, into clockwise direction or anti-clockwise direction. Similarly, if there's a force which is pushing it like this, F2, let's suppose this is F1, this is F2, and the distance between the perpendicular distance between the line of action of force and the pivot, it is, let's suppose this is D2, this is D1. So the product, this force would be turning it around the pivot like this. So this is the anti-clockwise direction. Anti-clockwise direction. So direction of the moment being generated, it is very important, first of all. Okay, and the distance would always be perpendicular to the line of action of force from the pivot. And there's one more thing, if there's any force which is being applied directly on the pivot, if there is F3 that is being applied on the pivot, this means that there would be no perpendicular distance, right, from the pivot. It is exactly on the same point of pivot, right? So distance would be 0. So there would be no moment generated. If the force is directly, the line of action of force is passing through the pivot point, then moment won't be generated. So the moment for this F3 would be 0 because the force is there, but there is no perpendicular distance between the line of action of force and the point of pivot. So this would be 0 Newton meter. Okay, and okay, this is simple. Okay, one more thing, for equilibrium, I'm just giving you the overall background, what the things would be included over here. Equilibrium, I think we have discussed equilibrium. There are for a system to be in equilibrium, there should be two conditions that should be met. So one of them is that there is no resultant force on the system or on the object. The resultant force is 0. Okay, the other thing is the resultant momentum is also 0. So this means resultant momentum means the moments are being cancelled out one way or the other. So this means that the if something is at equilibrium, then law of what do we say, equilibrium of this moments means that sum of clockwise moments would be equal to sum of anti-clockwise moments if something is in equilibrium. Okay, so the moments would be cancelling each other out. So these two things would be what do we say, met for a certain object or something system in equilibrium. So they can ask you to form we can now form equations using these two conditions, and then maybe we solve them simultaneously as well. So it all depends on the situation. We now know the conditions for the equilibrium. We now know how what is the moment and equilibrium, and here the forces can also be involved, right? The resultant forces over here. For example, if I say that this object is in equilibrium, that this complete system right now which I've drawn over here is in equilibrium. So this means that F1d1, which is producing the clockwise direction, would be cancelling out F2d2, the moment being generated by the force 2. And there's one more thing, that right now the moments are being cancelled out, but another condition that should be fulfilled is the sum of forces, the resultant force would be zero. So right now the forces that are being that are pushing this pivot down, pushing the this plank down, it is F1, F2, and F3. So the to overcome, to oppose these forces, there would be a resultant normal force at the pivot, like this upwards, which would be cancelling the effect of all three forces which are pushing it down. Now I can say that this plank is in complete equilibrium, because now resultant forces are also equal to each other. Oh, sorry, resultant force is zero, and the sum of moments around the pivot is also zero. Okay, do you get it?
Yeah.
Okay, but there's one more thing, that it's up to us. We can take the pivot to be any point on the system as well. Okay, if we know that the system is in equilibrium, then the sum of moments on any point, any pivot along that system would be zero. If I take this point as the pivot, then this is the force which is pushing it down, this is the force which is pushing it down, and the normal contact force over here would be producing the clockwise moment. This is producing anti-clockwise moment, this is producing anti-clockwise moment, right? This force, normal contact force, would be producing the anti-clockwise moment. Do you get it? Oh, sorry, clockwise moment, which would be keeping it in equilibrium. So if something is in equilibrium, then you can take any point along that length to be equilibrium, to be the pivot, and then you can work things along like that as well. Okay, when we'll do some examples, you will get a better idea. Okay, so let's take a simple question. um I wanted to take some easy questions first, but this is okay. Let's see if we have something. Okay, let's take this one. hmm These are all different past paper questions. So okay, let's see what this thing is telling us about the beam. You have a beam, look, ABCD. The beam lies on a horizontal step. You can see the step, horizontal step, with the end A on the step and the end B projecting over the edge of the step. Yes, we can see end B is over here and A is over here. And so dB is given to us. This is 1.3. This is 1.3. When a small boy of mass 30 kg stands on the beam at C. Okay, so there is a small boy standing over here. So his weight would be acting downwards, which would be 30 times G, right? 30 G. So on C, where CB is equals to 5, okay, 0.5, the beam is on the point of tilting. On the point of tilting means that right now this is in, again, what do we say, an equilibrium. Okay, find the mass. The boy is modeled as a particle and the beam is modeled as a uniform rod. Okay, so but right now look something like this. If I right now this is on equilibrium. So if I take this point D as a pivot, so the weight of this boy is actually causing clockwise moment around this D, and definitely you have a weight something in the middle, right? This is a uniform rod. They told us, and it is a uniform rod. Okay, so the weight of the rod would be over here. Weight of rod, which we don't know right now, but this would be generating anti-clockwise moment, right? So how much is the distance? Sorry, the mass of small boy, it is 30 times g, and the distance of the mass of this weight of boy from the pivot is this would be how much perpendicular distance? This would be 0.8. 1.3 minus 0.5, so 0.8. This is equals to the weight of the rod, which we don't know right now, multiplied by, they want the mass of rod. Okay, so mass of rod times g, and multiplied by the distance. How much would be this distance? Again, they have told us that this rod is a uniform rod, so the center of gravity would be exact in the middle. So this is 2.5 meters. So the distance would be 2.5 minus 1.3. This would be 1.2 meters. So m mass of rod times g multiplied by 1.2 meters. And now we just need to find the mass of rod, which would be 30g times 0.8 upon g times 1.2. How much is that? G and g would cancel out. So 30 times 0.8 upon 1.2. So 20. Mass of rod is 20 kg. Okay, do you get it? Let's check the answer. 20 kg. 20 kg. समझ आया? Okay.
Yeah, it's fine.
Good. We'll keep the second part right now on hold. Right now we'll just do simple first parts, so that once we understand the questions, and then we'll move on to the difficult parts as well. Okay. So in this one, two planks, a plank AB has length 4 centimeters, 4 meters. They've given you the plank. A mass of and a mass. Okay. The mass of the plank is 6 kg. The plank rests in a horizontal position on the two supports A and B. Sorry, B and C. AC is given to us 1.5. Load of mass 15 kg is placed. So this is 15 kg. 15 times G. Okay. Okay. The plank remains horizontal and in equilibrium. The plank is modeled as a uniform rod, and the load is modeled as a particle. The magnitude of the reaction on the plank at C is twice the magnitude of the reaction on the plank at B. So normal force at C and normal force at B. This is the reaction force, right? So magnitude of reaction on C is twice the magnitude on B. So you can write this normal force at C to be twice of normal force at B. Find the magnitude of the reaction force. Find the magnitude of the reaction on the plank at C. Okay, and the weight of the rod is also given to us. Weight of the rod was 6 kg, 6g, right? Okay, so first of all, we know this is an equilibrium. So the sum of forces would be equal to 0. So there are two forces upwards and two forces downwards. So 2 times NB plus NB is equals to, the forces downwards are 6g plus 15g. So NB would be equal to 21g upon 3. So NB is equals to 7g. So G is 9.8. You take G as 9.8, right?
Yeah, sir, 9.8.
हाँ तो कितना हो गया? 7 times 9.8, 68.6. So the normal force at C is twice. So twice of 68.6 is 137.2 Newton. Okay, I think this is the answer. Let's confirm. Do you get it? समझ आया? Look,
Yeah.
137.2. Then they're asking us to find the distance AX. This AX distance complete. Okay. So what would we need? Let's suppose this AX distance. Okay. There's a uniform for the rod is plank is uniform. So this means this 6G is definitely from here till here. It would be 2 meters, right? So this distance would be 0.5 meters, right? So AC was given to us 1.5, so this small part is 0.5. If we take the C as pivot, take C as pivot. So we have to analyze which force is producing which type of this what do we say? Which direction of the moment. So the weight of the plank, it is 6G multiplied by the distance from the pivot, it is 0.5, which is C. This is generating clockwise direction moment plus this x. Where is this x being placed? Where is this x placed? Do we know? A load of mass is placed on the x, remains horizontal and in equilibrium. Okay, so they have not given us this. Where is this x placed? So x is 15G, and let's suppose this distance to be equal to how much? Let's suppose this to be x. Okay, we don't know this x. So 15G times x. Both of these things are producing clockwise moment. And the only force which is producing anti-clockwise moment is NB, which is 137.2 times the distance from the pivot C, it is 2.5, right? Because this is the complete thing is 4 and this part is 1.5, so the remaining part would be 2.5 distance from the pivot. So this is 2.5. So can we get the value of x? That's what we need. So x is right now how much? So this would be 137.2 times 2.5. Okay, this thing minus 6 times 9.8 times 0.5. Okay, and then this 313.6 divided by 15 times g. 313.6 divided by 15 times g. So your x is coming out to be 2.1333. But they asked us for the distance of ax, the complete from a till x. So we have found out this distance from the pivot to the x. So I would just add 1.5, right? So ax would be this answer plus 1.5. So 3.6333. Okay. समझ आया? Do you get it?
Yeah, I got it.
So this is not very difficult, but okay. Let's do the next one. We have this thing left. Okay. We'll do this part as well. We'll come to this thing later. Mm, where's the question over here? Where's the question? Okay, let's see if we have something else. This question we did. Okay, let's try this one. Okay. A plank AB, mass is given to us 20 kg and length is 8 meter, is resting. Okay. Two supports C and D. Okay, where AC is given to us 1.5, DB is 2 meters. Okay, the package of mass 8 kilogram is placed on the plank at C. The plank remains horizontal and in equilibrium. The model, the plank is modeled as a uniform rod and package is modeled as a particle. Magnitude of the normal reaction between plank and support C. So first of all, we have the weight of the plank. It would be downward and it would be 20 times G. And the distance would be exactly in between because this is a uniform rod, uniform plank, 4 meters. Okay. So how many forces are there? There would be weight of this C, which would be 8G, and the normal contact at C. And this would be normal contact at D. Find the magnitude of the normal reaction between the plank and the support at C and D. Okay. Between the plank and the support at D, and between the plank and the support at D. Oh, C and D. Okay. We need NC and D. So first of all, I think we would need to form simultaneous equation. If we know this thing is in equilibrium, so sum of forces would be equal to 0. So there are two forces which are acting upwards, NC and ND, the normal contact forces, and two forces which are downward, which are 8G and 20G. So NC plus ND is equals to 28G. And then we also know that this is an equilibrium. So if we find the moments, let's suppose we find the moments around this, let's suppose this point A, it would be 0. So there are two clockwise generating moment forces, these two. So this would be 8G times 1.5 plus 20G times distance is exactly in the middle, so 4 meters, is equals to the two contact forces, yes, on C and D. So NC multiplied by 1.5 plus ND multiplied by 8 minus 2, because we need this distance from the pivot, always the distance from the pivot. So 8 minus 2 would be 6 meters. So look, these are the two equations that we've got, and then we solve them simultaneously. So you will get how much? 8 times 9.8 times 1.5 plus 20 times 9.8 times 4. So 901.6 is equals to 1.5 NC plus 6 ND. And from above we have NC plus ND is equals to 28 times 9.8 is how much? 274.4. Now we can solve them simultaneously. So 1.5, 6, 901.6. 1, 1, 274.4. So your NC is coming out to be 165.51 and ND is 108.89. Okay, समझ आया? Do you get it?
Yeah, I got it.
Easy or hard?
Yeah, this is okay.
Okay. Okay. So look, we're getting the right answer. FD is 108.8. Okay, and I don't know. Yes, 165.5. These are the two answers, right? Look, we've got it. I don't know why did I do so much working over here. Okay, let's do the second part. Maybe this part is a little bit tricky. There are some questions which are, I know, tricky, but most of the questions are very easy. The package is now moved along the plank to the point E. Okay, so let's erase all of this. The package is now moved along the plank to the point E. There is a certain point E we don't know. When the package is at E, the magnitude of the normal reaction force between plank and the support at C. Let's suppose this is the point E, and here is the new position of the plank. So the support, the normal reaction between the plank and the support at C is R. So the normal is R now. And the normal relation between the plank and support and plank and the support at D is 2R. So this is 2R. Find the distance AE. Okay. So AE, again we would have to do the moments thing, isn't it? So this is an equilibrium again, is now moved. The remains horizontal, normal reaction. Okay. Find the distance AE. So first of all, can we find the value of R? Because there is weight of the E. Sorry, first of all we can find R first, because we know sum of forces would be equal to 0. So we had the weight of the plank, which was 20 g in exactly the middle, and this is 8 g. So 20 g and 8 g is equals to the two reaction forces, which are R and 2R. So 3R. So R comes out to be 28 g, which would be 28 g upon 3. Right, this is the value of R. And now we need the distance where this E, the distance AE. Okay, so what can we do? hmm Now let's suppose, let's take this, the point C as the pivot. Okay, we can take any point, but let's take this point C as the pivot. So sum of moments around this point C is 0. So clockwise moments are 8g times x. Let's suppose this is x, we don't know. 8g times x plus 20g times, this is how much? This is total 4 minus 1.5, so 2.5 meters from the center of the plank to the pivot. 2.5 meters is equals to, anti-clockwise generating forces are 2R, right? 2R. So twice 28g over 3 multiplied by the distance is 8 minus 1.5 minus 2. We need this distance. So 8 minus 2 is 6. 6 minus 1.5 is 4.5. So now we can find the value of x. This would be, let's get rid of this thing, 2 times 28 over 3. Sorry, 2 times 28 over 3 times 9.8 times 4.5. This is the right part. Minus 20 times 9.8 times 2.5. Okay. And this answer divided by 8 times 9.8. So 4.25. So x comes out to be 4.25 meters. And but they asked us for the distance AE. So AE is the complete thing from A till E. So 1.5 plus 4.25. 4.25, right? So this thing plus 1.5. So AE is 5.75. Okay, समझ आया नादिया?
Yeah, I got it.
Good. And what about the last part? State how you have used the fact that the package is modeled as a particle. No idea. We have taken this mass of this package as a point load, right? When we take it as a particle means that it is a single point. So the load, the complete mass, we have taken it as a centroid, as a point load. This is how I think that we have stated how we have used the fact that package is modeled as a particle has a point load always at the centroid, right? That's a I have not written anything about this thing. Okay, no worries. We'll confirm this as well on the past repair. Okay, if there's any questions, ask or copy it down or make some notes, anything. This is question, it is January 2018. Okay, let's read the question. A non-uniform rod AB has length 6 centimeter total and mass of 8 kg. So this is a non-uniform rod, so this means that the center of mass is not exactly. The rod rests in equilibrium in horizontal position on two smooth supports at C and D, where AC, okay, DB cone. Magnitude of the reaction is twice than the magnitude of the reaction rod and C. Rod and D, this thing is the reaction at this place. This is twice the reaction at this place. The center of the mass is at G, where AG, we don't know where is G. This is X. Show that X is equals to 11/3. Okay. So first of all, what will we do? Anything, Nadia? Any suggestions?
Sir, I don't know.
We have two unknowns. Look, you don't know the reaction forces and you don't know the distance. So definitely you would need two equations. And you have two conditions, that the sum of forces would be equal to 0 because it is at equilibrium, and the sum of moments would be equal to 0 around any pivot point would be 0. Okay.
Yeah, okay.
This is G. So if I equate the forces, so the weight of this rod would be 8g, right? The mass is 8 kg. The weight is downwards 8g, and there are two reaction forces, R plus 2R. So you got the value of R from here. So R would be 8/3g. Okay. All good till here?
Yeah, it's fine.
Now you would do the moments around any point. Let's suppose your moment around, if you're taking A, around A as 0. So you analyze the direction the force would turn it into clockwise or anti-clockwise. So these two normal forces are turning it in anti-clockwise direction. So R, which is 8g/3 times the distance from A to C, it is 1, plus 2R. So 2 times 8g/3 times the distance from A to D, this thing is 6, this is 5, right? 5 meters. 5 is equals to the weight which is 8g times x. The distance from A till the center of gravity, which we don't know, is x. And now we can find the value of x. समझ आया? Do you get it?
Yeah, it's fine till here.
So 8 times 9.8 divided by 3 plus 2 times 9.8 times 5 divided by 3. This answer divided by 8 times 9.8. So 0.75 meters. So it's over here, this point. How is it possible? 0.75, it's so small. R is, let me confirm, 8 times 9.3, 9.8 upon 3 plus 2 times 9.8. Okay, 2 times 8 times 9.8. Look, I forgot. 8 times 9.8 divided by 3 plus 2 times 8 times 9.8 divided by 3 multiplied by 5, and this thing divided by 8 times 9.8. So 3.6666. Okay, now it's good. Okay, all good.
Yeah, it's fine.
Fine or understood? Do you have any questions? Ask.
No, now I understood.
Okay, okay.
It makes sense now.
Okay. The support at C is moved to the point F. Okay, the support is being moved. Okay, where AF is 2. So this C has now been moved over here. Let's suppose I'm erasing everything else. This is the new F. Okay. So AF is 2 meters. So this is 2 meters. Okay. The particle of mass 3 kg is placed on the rod at A. Okay. So there's a particle of mass 3 kg. So 3g is the weight downwards at A. And then the rod remains horizontal and in equilibrium. The magnitude of the reaction between the rod and the support at D is K times the magnitude of the support at F. So the magnitude of the rod and support, reaction rod and support, support at D is K times magnitude of reaction of rod and support at F. We don't know this K. They're asking for this K. So again, first of all, you would have to find the reaction forces. We don't know the reaction forces now. So reaction force at D and reaction force at F. Okay. First of all, this is again in equilibrium, so sum of forces would be 0. So there is weight of the rod which is downwards, which is 8g, and there is a weight of the particle which they added 3g, which is acting downward, is equals to the normal force at F plus normal force at D. Okay, now we have everything. And normal force at D is K times normal force at F. This is 11g. So normal force at F 1 plus K, right? Or something like that. Let's see. This is for the first equation that we got. Then the sum of moments as well is equals to 0. So if I take, let's suppose, this point as the, or let's suppose this, let's take this A point as well, as the pivot. So there would be no moment generated because of this 3g, because it is exactly on the pivot. So the only force which is downwards is the weight weight of the rod. So 8g times the center of mass, we have found it from the previous one, 6.6667, is equals to normal force at F times 2 plus normal force at D times 5. And normal force at F, we have found it out, right? Normal force at D is K times normal force at F. Again, we would need to solve this simultaneously. So what we can do is NF over here is equals to 11G upon 1 plus K. And this can be replaced over here. So 8 times G times 3.6667. This is 287.47 is equals to 22G upon 1 plus K and plus 5K upon not 5K, 5K multiplied by 11G upon 1 plus K. 1 plus K can go over there and multiply. So 287.47 plus 287.47 K is equals to 22G plus 55 GK. So 55 GK minus 287.47. So 251.53 K and 287.47 minus 22 times 9.8, 71.87. So K comes out to be this answer divided by 251.53. So 0.2857. Okay, do you get it?
Yeah.
This is just and the third part was the simultaneously solving them. Otherwise, I use the same. I form two equations using the sum of forces and the sum of moments, and the rest of it is the solution, right? Okay.
Yeah.
Take a screenshot or question to ask. Let's confirm the solution as well. January 18, question 7. January 18, question 7. What is the solution for K? K is 2 over 7. 28, 0.29 or better. 2 over 7 is how much? Okay, yes, we've got the right answer. Okay. 0.285. We got something like that. And 11 over 3. The first part was to show 11 over 3. So 3.66667 was, I think, 11 over 3. If we would have taken the exact answer from the previous part, then we would have gotten the exact answer over here as well.